Hi, Haas students. Happy Space Week. My name is Miss Golden, and I am a first grade teacher here at Haas. Today, I'm here with Missy Felix and Shannon Gata, who are rocket scientists for Blue Origin, a company that builds rockets that go into space. How cool is that, Haas students? Today, I will be asking them some of the questions that you submitted. All right, let's learn more about their roles. Hi, Missy. Hi, Shannon.
Hi,
Thank you
Andrea.
Hi,
so much.
Andrea.
Thank you so much for letting our school ask you some questions. Before we begin, can you introduce yourselves for the Haas students?
Hi, Haas. I'm Missy Felix, and I'm a rocket scientist at Blue Origin. I work in acoustics, which I can tell you more about later in the interview.
Hi, everybody. My name is Shannon Gata. I'm also a rocket scientist at Blue Origin, and I work with all the sensors, anything that blinks or tells you temperatures, all of that good stuff. You find it all around the rocket, and that's the thing that I work on.
Cool, awesome. All right, Haas students, we're gonna get started. I'm gonna ask them lots of questions that you submitted, and let's go. Here we go. All right, so our first question is, what is part of your job?
Missy?
Okay. Yeah, I can answer that one first. Part of my job that is, I think, the most exciting is that I get to be involved in lots of tests. As you in school, you'll probably do experiments where you have an idea and then you have to do an experiment or a test to test your idea. And then you look at the results of the experiments and see if your idea is correct or not. So a lot of what I do is doing tests and experiments to see if our ideas about the rocket are correct.
So cool. Awesome.
Yeah. In my job, I get to work with all these subsystems all around the rocket. So subsystems is that the rocket's so big, you have to break it up into sections, like who's doing the mechanical stuff versus the fluids versus all the electrical stuff. And that has to be divided up so everyone has something to do for their job. And I get to work with all these different groups and learn about their jobs so I can make their jobs easier to find their sensors.
Amazing. All right, thanks. All right, next question. What did you study in college?
In college, I studied mechanical engineering. Mechanical engineering is basically a general engineering where you learn all sorts of stuff about how things work and physics. So that's the basis of being a rocket scientist.
And in school, I studied data science. So there was a lot more computer programming that was involved for me. And because I didn't have the engineering educational background, I did a ton of internships while I was in school. I worked at places like NASA, as well as Stratolaunch and Ball Aerospace and other private aerospace companies. So I could have the engineering background while also being able to apply computer programming.
Oh, cool. All right. What do you find the hardest part of your job?
So the hardest part of my job is that, working in space is really hard. So kind of when you look at what we're trying to do is we're building a rocket our New Shepard rocket. We bring astronauts to space in a little crew capsule. So that's very cool. And then our New Glenn rocket it's a really big rocket. And we want to send satellites to space with that rocket. So when you're trying to do a problem that's solve a problem that's that big, there's just a lot of different environments that you have to go through. So, sending a rocket up through the atmosphere, there's a lot of forces that you have to anticipate. The material has to be strong enough. The engines have to be powerful enough. All of that kind of combines to being a really hard problem. And for me, I work in acoustics, so I'm trying to make the inside and outside of the rocket quieter. So the engines are really powerful to to get the rocket into space, and that means that they're super loud. And then when the rocket is going through the atmosphere, that's also loud. So those are the things that are probably the most difficult for me.
Yeah. And I would say in same, a lot of the work that we do is abstract as we're building this rocket for the first time. So a lot of things you have to anticipate what the needs are going to be and build out processes and systems that hopefully will fulfill the need of what we're looking for after our first launch. And also with that, you have a lot of people, like Missy had said, working on the rocket, doing different things all around. So people have different priorities and everyone's working to their own goals and needing to make sure that we're staying in alignment so we can all stay on schedule and launch this rocket.
Oh, interesting. Thank you. All right. Do you like your job and what is your favorite part about it?
I really like my job. I think it's super fun. Being a rocket scientist is great. Highly recommend doing that. My favorite part about it, I think actually one of the most fun things that I've gotten to do is, so I mentioned before our New Shepard rocket, where we bring astronauts into space on that in our crew capsule. So part of my job involves making sure that the inside of the crew capsule, that the noise levels are okay for the astronauts. Because there's all sorts of systems in there. There's fans, there's different cooling systems, things like that make noise. And then when the rocket is going up, all of the air pounding against the outside makes a lot of noise in there. So because that's part of my job, I got to go down to our launch site in Texas and participate in an astronaut like a test where I could go on the capsule and listen to all the sounds and stuff. So it was really fun getting to pretend to be an astronaut for a day and go in and have the experience of one of the astronauts that we send to space on New Shepard.
Oh, that's awesome.
Yeah, I definitely second the favorite thing to do is being the rocket scientist and being able to also work with other people like you, all these kids, and be able to tell them how great it is. Because I would love to just see more and more people who are watching this working alongside me in the future. And also with the challenging problems that come with being a rocket scientist, there's really anything can happen and it's all about like making sure that you are the most prepared and can be flexible with how you approach problems, which can make things very interesting from a day-to-day basis. So if I'm not interested in something that I'm doing, then I'll eventually get bored, as anybody does. So I just like being able to have things be dynamic within my job.
So cool. Thanks. All right. How does the rocket get the fire?
So I can answer that one. So the rocket, how does the rocket get the fire? So in general, it's a process called combustion. So if you have ever, ridden in a car, for example, that's the same process that makes your car go. So a car uses gasoline as a fuel. Our rockets use liquid hydrogen and liquid natural gas as fuels. And basically, you take a fuel and then you add in fire. And then, yeah, so you light the fuel and then combustion occurs. And then in our rocket engines, there's a nozzle. It looks like a cone on the outside of the rocket. And so the fuel that's been ignited goes through goes out through the cone, and that creates a bunch of fire and a bunch of thrust that moves the vehicle upward in the opposite direction. So basically, it's igniting fuel causes fire.
Yeah.
Cool.
And how
Interesting.
this, our engines that we build also, we don't just build rockets, we also build engines, and they're
Yes.
called the BE4, which is the blue engine number four. So then don't
Yep.
ask about one, two, and three. But BE4 is our largest engine to date, and it's also the largest LNG LOX engine that's ever been created. But we also think about sustainability when we're here, and we want to be able to make something that's going to be long lasting and also be friendly to the environment. So it requires less fuel than the usual kerosene burning engines that you might be familiar with, but it kind of goes out of the traditional box and extends to be more fully capable in both avenues.
Oh, wow, cool. That's really interesting. I'm learning so many new facts from both. The question, what is the rocket fuel made out of?
So the rocket fuel, we use liquid hydrogen, liquid natural gas, and liquid oxygen. So yeah, all the fuels are liquid because they are at really, really, really cold temperatures. And so yeah, we have to start them out at really, really compact and liquefied and super cold to get them ready to go in the engine.
Cool, interesting. All right. Have any of your rocket ships gone to the moon?
So it's really interesting you say that because we build a lunar lander at our company as well. It's like we have engines, we have rockets, and we also have a lunar lander that we're developing out with other space companies. So working together and being a team is super important. The idea is to be able to have this lunar lander land on the moon and transport people there eventually. So it's super exciting to be a part of that project as well.
Awesome. And I love how you said teamwork is really important. And that's what we work on in school. So it's pretty cool that you guys do that too in your job.
Mhm.
All right. How does a rocket ship take off?
So a rocket ship, so we talked about how does the rocket make the fire. So basically the rocket ship, we put the engines on the back of the rocket ship. So the nozzles are facing out the bottom. And then when the combustion happens and then you see the fire and you get the thrust, it pushes the rocket upward. So, usually sometimes the rocket is held down and then we would release a hold down. And then when the engines light up, then the rocket starts to lift off. And then as it gets further and further off of the launch pad, it gets faster and faster, and then you can go into space.
Cool. Wow. So interesting. All right. How do you fix rocket ships if they break in space?
That's a really good question. So traditionally, when we had a thing called space shuttle through NASA, they could get docked to this very big capsule that's in space floating just above the Earth called the International Space Station. And a way for us to be able to maintenance space shuttle at that point was people could go outside. People lived in the International Space Station and they could maintenance parts of the rocket that was needed. To this day, right now, if the rocket goes into space, it is fully autonomous, so it flies itself and it doesn't stay in space for too long at this point. So we're just kind of wanting to make sure that everything stays as together as possible during the launch till it re-lands itself on Earth, and then we can conduct more further maintenance.
Perfect. Interesting. All right. How long does it take to build a spacecraft?
So a spacecraft, it can take a while to build a spacecraft. So let's see, let's take a fun example like the Mars rover, for example. Like that's an awesome spacecraft that went to Mars and did all sorts of cool stuff there. So basically you have to uh, that spacecraft took years from the idea of, hey, let's build a spacecraft to go to Mars, to actually sending it to Mars. There's a lot of things as engineers that you have to consider. So first you start out with like, okay, what do we want to do? What are the requirements? What's the goal? And then, there's brainstorming about what does the spacecraft look like? And then, you make some decisions, and then the engineers come up with designs. They have to do analysis to see, okay, well, what are the forces that we have to make sure the spacecraft is strong enough? How are we going to manufacture it? All of those questions. And then, once you start building, depending on how complicated it is, it can take maybe a couple of years, depending on how complicated the spacecraft is. Another thing that's really interesting with building spacecrafts is that often they have to be built in a clean room because you have to make sure that, basically when you get a spacecraft into space, any sort of dust or debris on it, anything like that, can make it not work. And so in order to make sure that everything's working after it gets into space, you have to build it in a giant clean room. So people have to wear suits from head to toe and goggles and make sure that that there's not dust when they're putting it together, and that everything is ready to go. So it's a long process.
Yeah. Yeah, a lot of hard work, it sounds like. That's awesome.
Mhm.
All right. Are they planning to make a building or community on the moon?
So we have a lot of efforts, like we talked about with the lunar lander, and in previous past, we were doing things like orbital reef, which could be another like living environment, just as the International Space Station was. And ultimately, as a larger vision of Blue Origin, is to be able to have people, millions of people living and working in space. And places like the moon are something that's super accessible to us. It's where we can build things and also work within the environments. There are a lot of like chemical and material sciences that need to go to play to be able to sustain the very tumultuous environment that you have in space. But it is a goal of our company to be able to have these people living and working in space.
Amazing. So interesting. All right. How many sensors can you put on a satellite?
Well, it really depends on what kind of satellite and how big the satellite is as well. In another job, I used to work on building architectures for satellites, and you pretty much get requirements from your customers who's like, I want to have these kinds of sensors, and I want it to be about this big and this kind of heavy, and this is also our launch date. So it's like with all of these requirements, what can you build for us? So you really have to think about not just like how many sensors, but what kind and what's the mission that you're trying to achieve with this. We've had really big ones like the Hubble Space Telescope, or the James Webb Telescope, which are really big telescopes. It's really hard to imagine how big they are, but it's like I think a half of a football field for the Hubble Space Telescope, if I'm correct. But then there are also going to be really tiny CubeSats, which could be as big as like this, and then that can go to space. And all of them have different lifespans as well. Some can last 6 months. Others, like Hubble, have been up there for over 20 years at this point. I think we're now almost at 30 at this rate. So it's definitely really incredible, depending on like the longevity of how everything is going to work together. But yeah, you can put a lot of different sensors on a satellite.
Uh, uh, what are the parts of a spacesuit and how long does it take to build a spacesuit?
So the parts of the spacesuit. So basically there's a lot with a spacesuit, there's a lot of things to think about. You have like space itself is a really, really harsh environment. There's no basically there's no pressure in space, so it's a vacuum. And it's extremely cold. It's not very friendly for our bodies to be in space. So you have to think about the environment. So the material has to be durable and thick enough to withstand any anything that it might encounter outside of a spacecraft. You also have to have layers, so it's not just one material. You would start out with, an external material, and then there's insulation on the inside and things like that to keep the astronaut warm. There's also you have to think about the spacesuit itself is tends to be really big and cumbersome. And so, there's different, the astronaut needs to be able to use their hands with these like giant gloves on. They need to be able to use their feet. So there's kind of, different parts to help the astronaut move a little bit better. And then of course there's the oxygen. You have to have an oxygen tank and be able to pressurize the system so that the astronaut can breathe and so that their body is safe. Other parts, there's the astronauts the helmet so that they can see what they're doing if they're outside of the vehicle doing maintenance or other activities. So they have to be able to see. And then there's a sun visor because the sun in space, it can be very intense. So you have to have a visor. And then I think that there's also some cooling systems. So it's like, space itself is very cold. So you have to protect the astronaut against the coldness of space, but also you don't want them to get too overheated in all the layers. So there's a lot of things to think about with keeping the astronaut safe, but also mobile and able to do their experiments and maintenance outside of the spacecraft.
Wow, yeah. So it sounds like it takes a long time. It's really important.
Yes.
All right. Next question. How do you build a satellite?
How do you build a satellite? So it's very similar, I would say, to the kind of strategy we apply to a rocket. So you have to go through design phases, gathering the requirements to make sure that you're meeting the need of like, what do we want this satellite to do? Satellites can take pictures, they can sense things in the environment that they're being deployed to be able to get like temperature or maybe longevity of testing out some kind of technology. There's so many different functionalities a satellite can provide. Ultimately, your satellite can be, very small, like we had talked about, being a CubeSat. I was able to build a CubeSat while in college. They're not very hard to make, but especially when you have a really great team who knows how to make them. But also, doing the larger satellites can take many, many years. So, going through the design phases, going through testing, making sure that everybody who has a part of the satellite is following through. You have to make sure that it's going to go through cleaning, that there's not just any random like nuts and bolts just falling out of it, vibration testing even. It really depends on what the satellite's purpose it's serving, of what kind of test it can go through. But like Missy had said, it's a very cold environment. So cryo testing is another option where you try to make it as cold as possible to see that everything still works operably during its function process. Also, the kinds of propulsion that it might use, it could be liquid, it could be a solid rocket fuel to be able to burn slowly over time, because you want a satellite most of the time to be somewhere near Earth and stay just out of the orbit of Earth so it doesn't come crashing back into the Earth with gravity and just kind of like stays just above the line, whether in a low Earth orbit or the orbits beyond that as well. So yeah, it's once you finally get everything like tested and cleaned up, then you can like ship it to wherever you're going to be launching it from. Usually, if you're building the satellite and you have a rocket, then that's great. You can launch it yourself, or you can find another provider like United Launch Alliance or some other company, or even us. We launched a lot of satellites for the government as well as for NASA and other even small time companies to be able to get their payloads to space and launch them as well. So yeah.
Cool. Awesome. All right. How do someone's senses change in space? So, for example, how does it smell in space for a person, or how does space affect someone's sleep cycle?
So I can talk about that a little bit. So, as far as the senses, I think a lot of the information that we have is from the International Space Station because there's been so many astronauts that have lived there for, just stay visited for a little while or lived there for like over a year. I think that there's been astronauts who have stayed for a long time. So they there's the International Space Station is pretty crowded. There's a lot of equipment. There's, people have to, live in the quarters, and so, as far as smell goes, so I've heard, there's a lot of different smells. You have, if you can imagine, a bunch of people kind of all living in the same space for a little while, there can be some interesting smells, and the fact that the when you're in a spacecraft, when you're on the Earth, right, you have all of this fresh air, you can just open the window. But when you're in space, you have air that's just recycled, and reused. So, while everything is clean, it might not smell the best, as like a fresh air or like going to like a field near your school or something like that. As far as other senses, so hearing, so space, there's no sound in space because there's a vacuum. There's no pressure to support any sound waves. So it's completely silent in space itself. And then, in the space station, so you don't have any noise on the outside, but you've got a lot of noises on the inside. So, you can, what maybe a computer might sound like. So some buzzing, like your fan going off, a toilet flushing. There's toilets in space. Maybe not how it's not like your toilet at home, but there are toilets in space.
Mhm.
And then so you can kind of hear, lots of different sounds happening, both from the equipment and then also just from the people that you're living with on the space station. And then I'm only addressing two of the senses. So let's see, taste. I'm not sure about taste. I haven't heard of any like changes specifically in taste. I don't, Shannon, I don't know if you, yeah.
Yeah. So things like your sense of sight and taste can wear over time. So some very famous astronauts that, of course, the name is slipping me right now. The twins. Please tell me the twins' names, Missy.
Oh,
Mark
Mark.
and
I'm forgetting the other twin's name. I'll look it
so
up. I'll look it up.
yeah, there was a really great experiment that they had done where two astronauts were sent to space. They were a pair of twins. So they had one astronaut stay on, no, not go on this trip, and the other one was up there for almost a year, I want to say. And through that time, they tested the differences between what had changed in one of the twins that went up to space over time versus the one that stayed on ground. And it's very common for a lot of astronauts, including this one in particular, who had to start wearing glasses just for an adjustment period. They didn't have to after a while, but the lack of gravity and the way that things have shifted when they're up in space made them lose their eyesight slightly. And this is the same as well when it comes to things like your muscles deteriorating. Exercise is something that they have to do in space just to make sure that everything will work. Because when you're floating around, you don't have to like bear the weight of gravity to walk everywhere. You're just floating through space. So they have to get on machines and ellipticals where they're strapped in and having to move against points of pressure to essentially be able to build up their muscle and to keep it in working shape as well. What were the names, Missy?
Scott and Mark Kelly.
Kelly, thank you.
Yeah.
Yes.
Wow. Wow, that's so interesting. And what about their sleep cycle? Are they sleeping the same amount of time as we do on Earth?
Oh, See, what usually you're sleeping and waking up to is daylight because it's like, oh, now I know it's morning because it's bright outside. Whereas when you're in places like the International Space Station, you go around the Earth like every 90 minutes. So you only get a small amount of time that's actually going to be dark. And there are windows that exist on International Space Station, but for the most part, people just have to simulate darkness and wear eye masks and just kind of go into bed and be tucked into their little cocoon for a certain amount of time. So their schedules for the astronauts on board are very, very tight. It's like every single minute they're being dictated to conduct this research or to do this job, as well as their sleep schedules. So they get the amount of sleep that's needed. It's just something that you have to institute as a routine over time, just as with anything.
Oh, interesting. All right. What was the biggest rocket that was built?
So the Saturn V is the biggest rocket. As far as its height, and the Saturn V is the rocket that sent the Apollo missions to the moon. But when you look at the rockets that both the rockets that have launched, but also ones in production, our New Glenn rocket is also pretty tall. It is, I'm not sure if it's the second tallest, but it's up there. So when for rockets to basically depending on how far outside of Earth's gravity you want to get to, that can have longer stages, can have multiple stages. So that's kind of what dictates how tall a rocket is.
Oh, cool.
Mhm.
All right. We have one last question. What is the G force in the rocket ship?
So, so the G-force in a rocket ship. So the G-force, it depends and it can vary depending on what rocket you're in and how fast you're going. And then even, on in one rocket trip, you start off not moving and then you accelerate and you get a lot faster. So like, for example, our New Shepard rocket, it starts out not moving. So if you're an astronaut, you're just feeling normal gravity. And then as you get faster and faster, the G force increases. So the New Shepard rocket goes a maximum of Mach 4, which is 4 times the speed of sound. That's really fast. And as you're getting up to those speeds, you feel an increasing kind of force. If you I motion to my chest because the astronauts usually are reclined. So, you kind of feel the G force as going kind of downward in your body. But yeah, you feel, if 1G is just the Earth's gravity, 2Gs is 2 times the Earth's gravity. So you would feel, that pressure on your body. And I know that they're in astronaut training, like for NASA, at least in the past, they would do, G-force training just to train your body and your mind to be resilient against those forces. Because usually, as we're walking around on the Earth, we're just experiencing 1G. And then if you, if you increase the G's by too much, then, you could pass out. So,
Wow.
so people have to train for that. Of course, on our rockets, we don't, all the astronauts are safe and we don't go that fast, but that's kind of the range of how G forces can affect your body.
Interesting. Wow. Wow. Missy and Shannon, thank you so much. This was incredible. Haas students, I'm sure you were probably so excited to have learned all of these amazing facts. And it was so awesome that you both were able to answer the questions that the students in Haas submitted. So we thank you so much. We're so excited to keep learning about space this week for Space Week, and we appreciate all of the knowledge that you shared with us about being rocket scientists and all about space. So thank you so much.
Thank you so much for
Thank
inviting
you.
us. And thank you for meeting with us, Haas students. I hope that you had a great time. And hopefully you filled out your Club for the Future postcard so you can send your own postcard to space.
Yes.
Yes, I also have my postcard that I sent to space. So definitely do that. And it'll be super exciting when you get them back. We'll send them to space in New Shepard, and then we'll mail them back to you. And thank you all so much. And enjoy the rest of your Space Week, Haas students.
Thank you. Thank you so much.